Hey, hello, welcome back. Um, in this lecture, we are going to discuss the eight queen puzzle implementation. Okay, and we are going to use the backtracking. So backtrack basically to use stack to store the moves. Okay, so for the n queen puzzle, it's you have eight queens, and you want to put it to this 8 by 8 board. Okay, but there is a rule: no two queen can be located at the same row, same column, or diagonal. Okay, okay, then let's see how do we solve it. Okay, so here we use a two-dimensional array. Okay, and to remember where the location is for the queen. So we start at the bottom left, so it's 0, 0. So of course, no conflict, so we just put it to the stack. And then we start at the second row. Second row, so this conflict, so here conflict. And when we move to the third column, no conflict, so we keep it there. And then we add another queen, okay? So we can find it's at this location, so 4, 0, then there is no conflict. And then we add the fourth queen, okay? And we can see the fourth queen, when you put it here, it doesn't conflict with anyone, okay? So it should be 6, 3, okay? And then when we add a new queen, okay? Add the new queen, and then we can find no matter where we put, it's always a conflict. So when we push it to beyond the board, then we don't have a solution. Because there is no solution, then we need to backtrack. So here's what the backtrack comes from. Okay, so we pop this queen out. Okay, and then we move it right by one column because next one we still have space. We still have the column available, so we can push it to 7, 3. Okay, and after we push a 7, 3, then we can check. Okay, if the fifth works, etc. So we push it to 7, 3. And we check if the fifth works. Then you may find, yeah, it did work. Is it okay? It may be here. Then it works. So it's this is the fourth. Okay, so 4 should be here, and then the 1. Okay, that 1, 4. 1, 4, was it? And the same thing when you have another, then you just move up to the next row and find a location. And if it conflicts with any of the queens, then you need to just pop them out, and move it, shift it to right one more, and then see if it is still conflict. If it's not, then that means you find it. Okay, so that's how we use backtracking strategy to solve the 8 queen puzzle. Okay, and this kind of backtracking can also be used for to find a path out of a maze. Okay, and then next let's take a look our implementation for the 8 queen. Okay, and so the implementation in the Java Stack example 6, the n queen. Okay, and in this example, you can see we define a class for our queen. So you just remember where the row and the column is, okay? And the queen is initiated at a specified row, okay? And the column always start at 0. And you can get the row and column, and we can also do the shift. So we always shift to right, so the column increment by 1, okay. So that's this queen class. And then we have this solver for the in queen. And over here is depends on the n key. Is it 8 queen or 9 queen or something? Is it? And we use a stack of the queens to keep a record of all of the moves. And also we also use an integer number to keep track of how many rows already filled. Okay. Okay, so the solver first it initialize the queen to an empty stack, and the field is 0. Start at the first row, okay. And then what we do is next we try to solve the problem that so if the field hasn't reached to the top row that and then if the current queen is null, then you start the new row that and then we are going to do the column that move. So here basically move the queen. And if there is a conflict, then you shift right. Is it? If there is no conflict, then you add the queen to the stack and also move up the row, 1 row, is it? And then get the queen back to the now. And then start the next iteration, is it? Next iteration. Okay, and okay, if when we move at a specific row, that move the queen out of the column bound, okay, column bound, then we need to pop the queen out. And then try to do the right shift and fill, is it? And then process it again, okay? So after we finish off the field, then you can write the result to an array. So here is the result of the array. So write to, so has conflict, it's just check row and column. And for the write to array, so initially you just fill the array. So always a dash, is it? And then over here, what we do is we convert the queen stack. So the stack of queen, okay, to an array, okay, to an array. And then we do the loop to get each of the queen location out, is it? Get its row and column, and then fill it with that queen, okay, with that Q. After this, we just convert to the result. So we just get the result to a string builder, okay, and then convert to string. And then you get the output. So the driver is pretty straightforward. It's you just, so we have a 4 queen, we have the 8 queen, just output the result, okay. And we can see, yeah. So over here, we have this 8 queen result. You can see, yeah, it does some move. If you recall, for the third row, it changes. And for the second row, it's also changed. Why? It's because when you place the following queen, it go beyond of the bound, then you need to pop the previous result out and do the right shift. Okay, so that's about the discussion of the stack chapter 12. Okay. So in our next lecture, we are going to move to a new chapter. Okay, see you.